Here, problem 6, I give you n equals to 1 mole of an ideal monatomic gas is taken through the cycle shown in the figure. Okay, first of all, we have an ideal monatomic gas. When I say monatomic gas, it means we have gamma, adiabatic constant gamma, equals to 5 over 3. You know, gamma equals to L plus 2 divided by L. In the case of monatomic gas, L equals to 3. In the case of diatomic gas, L equals to 5. Uh, First of all, the process AB is reversible isothermal expansion. Expansion, it means we have an increasing of volume. And um, as you see, we have BC, it's in isobaric process where P is constant, and CA is isovolumetric process where V is constant. Part A. Find the net work done by the gas. When I say net work, it means we have to calculate the work done during one cycle. You know, in the case of a closed cycle, delta E equals to O, equals to the Q of the cycle minus the total work done by the gas of the cycle. So we can, I want to calculate the work done by the cycle, which is equal to the area here in this zone, but we cannot calculate it because we don't have a fixed geometrical calculation to calculate the area between the curve. In this case, we have to find the summation of the work of AB plus BC plus CA. Okay? First of all, you know, CA is a volumetric process where the work omega CA equals to 0 because V is constant. We can say omega CA is 0. So we have to calculate omega AB and omega BC. You have to know, in the case of AB, we have an isothermal process, so omega AB equals to Q AB equals to N R TA or TB. We have the same T. Let's say TA ln VB divided by VA. You know, in the case of AB, we have an increasing of volume. Volume increases. In this case, omega AB must be positive. If you look here, as VB is greater than VA, so ln VB divided by VA is positive. And as we have nRT, these are a positive, these are positive values. In this case, we can say QAB is positive and omega AB is positive. Okay, we have VB, we have VA, because VA equals to VC. We can calculate omega AB equals to N times R equals to 8.31 times TA. I don't have the value of TA. or TB times ln VB equals to 50 divided by VA equals to 10. We don't need to convert the unit to meter cube because we can eliminate 10 power minus 3, 10 power minus 3. To calculate omega AB, we have to find TA. Okay, but as you see here, I don't have, in order to calculate TA, we can use PV equals to nRT, but the problem here, we don't have, let's say, okay, we can say directly, PV equals to nRT. So PA VA equals to nRTA. We can substitute the value of TA equals to PA VA divided by nR, or you can say directly nRT equals to P times V. Okay, so we can write here equals to PA VA times ln half, uh, VB minus VA. Here you have 50 divided by 10, okay, equals to 5. So equals ln 5 equals to PA. We have PA equals to 5 atmosphere. Be careful, you have to convert atmosphere to Pascal. We have to write equals to 5 times 10 5 Pascal, 180 M equals to 10 5 Pascal, times VA equals to 10. You have to put it in meter cube, equals to 10 times 10 power minus 3 meter cube, and ln 5. Finally, the answer of QAB equals to omega AB equals to, I want to calculate, 8.15 times 10 power 3 joule. This is the value of omega AB. We can write here omega AB equals to 8.15 times 10 power 3 joule equals to QAB. Okay, because I repeat here, delta A equals to O. In the case of isothermal process, we have delta EAB equals to O equals to QAB minus omega AB. So QAB equals to omega AB. So here equals to 8.15 times 10 power 3 joule. Okay, part, no, we have to find now omega BC. As BC is isobaric process, and between B and C we decrease the volume, so omega must be negative. Okay, omega BC is negative, and as we have an isobaric process and always the work is the area under the curve, So we can calculate the area of this zone, which is equal to 40. Okay, from here to here we have 40 times 1. Okay, so we can say directly 40 times 1, or you can apply the equation of the work equals to pdv between b and c. We have a constant p equals to 1 atmosphere equals to 1 times 10 5 Pascal. V equals to V final, V final, uh, V final, VC minus VB equals to 10 5 Pascal. VC equals to 10 minus 50 and times 10 power minus 3 to convert this value to meter cube. Okay, we get finally here omega BC equals to, we can calculate its value in joule, equals 4.05 times 10 power 3 joule. This is omega BC. Okay, this is the total work done by the cycle equals to omega AB plus omega BC plus omega CA, which is equal to 0. So here, be careful. We must have a negative value here, minus. Okay, because we have here 10 minus 50. Okay, the total work in general, if we have a clockwise cycle, the total work done by the gas must be positive. Okay, must be positive because we have a clockwise cycle. It's a heat engine. So here we get omega BC is negative here, and we have omega AB equals to 8.15 times 10 power 3 minus 4.05 times 10 power 13 3 joule. We do the calculation to get the answer. Here 4.11 times 10 power 3 joule. This is omega of the cycle. As I said before, it must be positive because we have a clockwise cycle of a heat engine machine. Okay. B, find the energy added to the gas by heat. When I say the energy added, so we have to find Q hat. Here, we don't know which one Q hat and which one Q cold. Okay, you have to know exactly the positive value and the negative value. Anyway, as Q total, we have QAB, we have QBC, and we have QCA. I want to find the energy added to the gas by heat. I want to find Q hat. I want to find Q hat. So we have to add all the positive value of Q hat. First of all, we have QAB is calculated, which is equal to 8.515 times 10 power 3 joule. It's a positive value, so it's one term of Q hat. we can say QAB is positive. First, so we have to calculate QBC. In general, uh, we have B constant. Uh, we calculated omega BC, and we can, to calculate QBC, in the case of P constant, we can say directly NCP delta T. Okay, you know CP equals to gamma R divided by gamma minus 1, okay, equals to gamma 5 over 3 R divided by 5 over 3 minus 1. We can say here directly 5 over 3R, okay, uh, 5 over 3R times 3 over 2. Uh, we get here 5 over 2R, okay? So like this, we calculate CP, which is equal to 5 over 2R. We need to calculate CP because we have to calculate QBC, where equals to 1 times CP times T final. We have T between B and C, TC minus TB. As you see, between C and B, we decrease the volume. So omega must be negative. Anyway, we have to calculate TC and TB in order to calculate QBC. So we have P, we have V, we have an R, we can calculate T. So TC equals to PC VC divided by NR equals to PC equals to 1 times 10 Pascal. VC equals to 10 times 10 power minus 3 m cubed divided by 1. We can put here R, okay? And the same TB equals to PB VB divided by an R equals to PB equals to 1 times 10 5 Pascal times VB, which is equal to 50 times 10 power minus 3 divided by 1 plus R. We substitute the value of TC and TB here to calculate QBC equals to 1 times 5 over 2 times R times we have TC equals to uh, 10 power 3 over R TC minus TB, which is equal to 5 times 10 power 3, okay, divided by R. We calculate QBC. We can eliminate R and R like this. We get finally the value of QBC equals minus 10.1 times 10 power 3 joule. This is QBC. It's a negative value. So let me write here its value. We have QBC equals to minus 10.1 kilojoule. It's a negative value, so it's Q cold. It's not Q hot. We calculated QAB. We calculated QBC. We have to calculate QCA. It's an important problem to practice the calculation of heat. Anyway, CA, we have an isovolumetric process or isochoric process. So QCA equals to NCV delta T equals to NCV. We calculate its value equals to equals to R 3R over 2. Okay. Okay. Times delta T. Delta T equals to T final between TA minus TC. We calculated already TC equals to 1 times 3R over 2 times, TA equals to TB, as we have in isothermal process, TA equals to TB. We can substitute the same value of TA and TC here to calculate QCA. TA equals to PAVA divided by NR. We can say PA times VA divided by R minus TC. TC equals to PC equals to 10.5 Pascal. VC equals to 10 times 10 minus 3 divided by R. Okay, we do the calculation. We can eliminate R like this. You get finally QCA equals to 6.08 kilojoule. This one is QCA. So we can calculate the total Q hat. We take only the positive value. We have Q hat equals the positive value. We have only QCA and QAB. QBC is negative, okay? So we have QAB plus QCA, which is equal to 6.08 kilojoule plus 8.15 kilojoule. We can say we have about 14.2 kilojoule. It's Q hat. I advise you to put all the results in a table beside in order to uh, see all the calculated values of heat or of energy. You can use them directly. Here we have 14.2 kilojoule. Okay. We go to the next. Calculate the energy exhausted. Exhausted, it means released. Released from the gas by heat. I want to calculate Q released. It means Q negative. Here I want Q negative, Q cold. We calculated already Q cold, which is equal to minus equals to QBC equals to minus 10.1 kilojoule. Okay, no problem. You can calculate one problem. You are not obliged to respect the order of the question. Okay, we go to part D. Find the efficiency of the cycle. You know the efficiency equals to the total work divided by Q hat, or equals to 1 minus Q cold divided by Q hat. You can use any one. We calculated already omega of the cycle, which is equal to 4.11 times 10 power 3 joule divided by Q hat, which is equal to 14.2 times 10 power 3 joule. The value must be less than 1. Okay? It's 0.28, or you can say 28% of efficiency of this machine. That's all about this problem. I can add part E. Determine the entropy of the cycle delta S. You know, delta S of the cycle equals to delta S of AB plus delta S of BC plus delta S of CA. You know, as definition, delta S equals to the integral of dq divided by t. Let's start by AB. AB is isothermal, so delta S AB, where T is constant, equals to dq divided by T. As T is constant, we can put it outside, where we get here 1 over T integral dq. In the case of integral dq equals to q, so here we get q divided by T. We are talking about AB, so we have Q AB divided by T, TA or TB. We calculated QAB and T. We come back to the answer. You know, uh, here we calculated Q equals to 8.15 times 10 power 3 joule, and we have TAB, TA equals to TB equals to 5.05 times 10 power 3 divided by R. We calculated its value. It, it's 13.4. What about this one? What about delta S B C? Okay, B C equals to dq divided by T equals to dq as we have P constant, we can say, you know, uh, delta Q equals to N Cp delta T, and dq small quantity of Q equals to NCp delta T. So we can write NCp delta T divided by T. Okay, so between B and C, we get here NCp times integral of delta T over T equals to ln T. So equals to ln T final divided by T initial. Okay, you know, we have N equals to 1, Cp equals to, we calculated Cp, you know, equals to gamma 5 over 3 R divided by 5 over 3 minus 1. We can say 5 over 3 times 3 over 2 R. We get 5 over 2 R. This one is Cp. So we have 5 over 2 R equals to 8.31 ln T C divided by TB. We have the value here. We can back. Uh, anyway, let me okay, here we have the calculation of delta S. Okay, we continue here. So delta S equals to NCp delta T. Finally, NCp ln TC. Okay, I'll write here NCp ln TC divided by TB. Okay, so as you see here, we have N equals to 1, Cp equals to 5 over 2 times R ln Tc divided by Tb. Okay, we get finally the answer will be, it will be minus 33.3. You know the unit here, we have joule per Kelvin. This is delta S B C. We have to calculate delta S CA. You know, in the case of CA, delta S CA equals to the integral of dq divided by t. Here we have dq equals to NCV delta t because we have a volume constant. So we have NCV delta t divided by t equals to n times CV equals to R divided by gamma minus 1. We calculated before. I repeat, CV equals to R 3 over 2. Okay, we have 3 over 2 times r, 8.31. The integral of delta t between c and a equals to ln ta divided by tc. Also, we calculated the value of ta and tc. I come back to the result. So we have here Ta divided by Tc. The value will be 20.185 joule per Kelvin. Now I want to calculate delta S total. Delta S total of the cycle equals to delta S AB 13.4, delta S BC minus 33.3, delta S CA equals to 20.185. The summation will be equals to 0.28 joule per Kelvin. Okay, anyway, it's a irreversible cycle. Okay, you know it's a positive value, so as conclusion, it's irreversible cycle. If delta S of the cycle equals to O, we say reversible cycle. Okay, anyway, it's not far. Okay,